My talk will be on Flutter. The title for this talk, Flutter at Pinch. So I'd like to wish you a good afternoon. Thank you all for being here. 2 weeks ago, I got this message from Redmer, and he asked me to join you for the GeekTalk. So yeah, I was inclined to see what this was all about, and he asked me if I was willing to share a bit of my experience, so actually our experience at Pinch with Flutter. So yeah, let me tell you how that went. My name is Stephan Mantel, and welcome to my talk on Flutter. I'll first start with a little introduction of myself. So let's first get into yeah, a bit of that, so you know who you're listening to. I mentioned Pinch, so I'll tell a bit of that. Then about Flutter, what Flutter is. I'd like this to also be a little techy, so let's get into Flutter in practice. I'll talk about how Pinch started using it. We do in-depth code and technical stuff, some pros and cons and learnings, and then we close off with a Q&A. And if there's time, I can even open an IDE and we can look at some code if you all are interested. I'm going to assume the varying levels of expertise and technical experience. So I'll do both a little bit of high over as well as more technical and down into the code stuff. So I hope I can make this a comprehensive talk for all of you. So let me start a bit about myself. Bima did already a little introduction, so I'd like to continue on that. And that you know a bit who you're listening to. So my name is Stephan, and I'm 28 years old, and I live in ICEHOUSE in the Netherlands, which is a city close to Amsterdam, where my company is located. My hobbies include snowboarding, sailing, programming, video games, sports. I've been doing Android development since 2014, and I have joined Pinch at 2016. And I know ICEHOUSE because I worked here I worked in Jakarta in the first half of 2018 for ICEHOUSE, doing a project for Sinarmas. So that's how I got involved with ICEHOUSE, and that's how Redmer knew me. Then a bit about the company. My company, I've put it in the title of the talk, so it'd be great if to let you know what that is about. Pinch is the company I work for and love since 2016, so it deserves an introduction. Pinch is just like ICEHOUSE, a software agency doing mobile development. We've been developing mobile apps since 2011. We're based in Amsterdam. We're a mobile development agency, so we focus only on iOS and Android. Initially, even only iOS, and Android came along later. I think a year or 1.5 years before I joined the company. And I joined in 2016. And so that's already almost 5 years ago. As an Android developer, I've worked, as Bima said, on a few high-profile apps mostly for the Dutch newspapers, the Dutch Telegraph, NRC, which are rather large national newspapers in our country. A couple of radio stations, some charities, like maybe you've heard of the Make-A-Wish Foundation. We've done an app for them, and more. Having that out of the way, you know a bit about my background and about Pinch. Let's get into the topic of today, Flutter. You might already have known about it, but let me still answer the question, what is Flutter? Flutter is, in essence, a UI toolkit. and it's made by Google, and it's initially released in 2017. So yeah, like I said, it's in essence a UI toolkit, but in practice it's more than that. It's a platform with the promise of one code base for multiple platforms. Primarily, it focuses on Android and iOS, but it also is possible to make desktop apps for Windows, macOS, and it's even possible to deploy your programs to web. But at Pinch and also in this talk, I will put the focus only on mobile platforms, Android and iOS. Now, Flutter was not the first to come up with this idea. The idea of a multi-platform app with a single code base has been explored before. I've listed a couple of them. This is not an exhaustive list, but we've already seen React Native, which has grown quite large, Xamarin, Cordova, which started as PhoneGap, and even some that are still in development. Kotlin is gaining traction for multiple platforms in the form of Kotlin multi-platform or Kotlin native. And even Swift, the language used on iOS, is being more and more available on other OSs. Therefore, it also might be a candidate. You can already share code between iOS apps and macOS apps, but you can also compile Swift on Linux nowadays. So that might also be one of the candidates to solve the same problem. But let's not get into all these other techniques. We're here to talk on Flutter. So this is the way things went at Pinch, how we started using Flutter. So like most of you, I expect we always keep an eye out for new technologies. And this was also the case in 2017 when I myself had gained some experience working for another client with React Native. This was the first of the multi-platform applications to code bases that we made, first tools. And we tried to, if this was a thing for us. This first we needed we started experimenting with it, but we got a client somewhere halfway 2017 who was willing to take a risk because they knew that React Native was new for us, and they wanted to have us make an app in React Native, and so we did, and it was a great learning experience. I think we worked on it for about half a year, and ultimately the client was satisfied with the product. But we had quite a few doubts ourselves. It had been hard to maintain a smooth operating app. It was quite a few hassles that we hadn't foreseen that were very easy to do native and very hard in React Native. It was we had issues with threading. React Native is basically single-threaded. So when we had to do calculations, it was hard to do without blocking the app. React Native depends on and is written in JavaScript, so we had no compile time errors, which was a bummer. We had only runtime errors. So ultimately, we decided to not use React Native again. But Flutter was not out of the question, or it was not even in the picture yet. But the next step, when it came along, was that we organized a TEFCA. And I should explain a bit what that is. A TEFCA is a word that we made up, but it is the name for a 2-day event that we have at Pinch every once in a while, every 2 months or so. It is a 2-day event where we can work on anything. You can work on anything you like. If you want to refactor a bit of code somewhere, maybe try something out entirely new, go all out of the way to explore new platforms. In other words, it is an event that is aimed at experimenting. So one of the experiments that we wanted to do that time, was Flutter. It was a new thing. We had heard of it, but we didn't really know what to expect, what it could be used for, and if it was any good. So we, a couple of guys, we decided to use this Stefka to experiment with Flutter. And after 2 days, we already got a tangible result. The next step in our Flutter journey came, I think, half a year later or so, when there was a client willing to try it out in a production app. Again, they knew that this was a new thing for us, and they were willing to take a risk. They were willing to try. They knew it was new. Also, one of the things that was vouching for us was an external developer that we had hired, who had already had experience with Flutter, and he even has some apps in the Google Play Store and the iOS App Store that were made with Flutter. So, learning from this guy, from him, we were confident enough that we could make an actual app in Flutter. That was going to that the client would be satisfied with. And so we did, and along came our second Flutter project. This time it came along because the client had a good idea for an app, but not the budget to have an app made for both iOS and Android. And at this stage, we had gotten some more confidence in Flutter, and we had been making an app with it for a couple of months. And we decided that it could be a cost saver, a time saver, if we used Flutter. So we proposed it, and again, they were willing to take the risk so that we could try to reduce the cost. So that brings us to where we are now. And both apps are released to the app stores, the App Store and the Google Play Store. And the first project went rather smoothly. Of course, there were hiccups and a learning curve, but it was ultimately a smooth experience. The second project, unfortunately, took quite a lot more time. This has not all to do with Flutter itself, but it might have played a role. The second project took quite a lot more time than we expected. It has ultimately been released, and both apps are now in active development and are being used right now. All right. So that's been a bit of the journey that we've taken to get to the point where we are now. 2 apps in development, and gained some expertise in using Flutter. So let's get into the more technical side. How does Flutter work? This is, after all, a GeekTalk, so let's get geeky. Before you can start to code, you have to choose an IDE. The most used options that are available for Flutter are Visual Studio Code by Microsoft and Google's Android Studio. Because I'm an Android developer, I already have experience with Android Studio, and I like the IDE, so I chose to use Android Studio. But regardless of which one you choose, there are great plugins available. There's a Flutter plugin, as well as a Dart plugin, the language, that you can install on both Visual Studio Code and Android Studio. And those plugins handle quite a lot for you. So if you want to run the app, they build everything. And if you want to run on iOS, they use the Xcode command line tools for you, so that it can immediately talk with Xcode to create an iOS build. Maybe redundant to tell, but this does mean that if you want to create an app for iPhone, you still need to have a MacBook or an Apple PC running macOS with Xcode, so that you can actually deploy for iPhone. With the tools set up, let's get into more the details of how it works. I have a feeling that I'm missing a slide. Anyway, let's. In Flutter, everything is a widget. As I've said before, it is a UI toolkit. So I'm looking at this from the UI perspective first. Flutter makes use of the concept of declarative UI. This is a pattern that's also used in React Native, Swift UI, Jetpack Compose, and more. And the idea is that all the visuals are composed sort of like a tree. And in Flutter, everything is a widget, down from the biggest widgets, the screens or navigators, and down to everything, the smallest things, buttons, images, text views, everything is a widget. And widgets can contain other widgets, and that way you can make a tree of widgets to build your UI. So some widgets are visual, text, buttons, images. Some are used to lay out other widgets horizontally, vertically, in any order you like, adjust the layout, but also still widgets. And some widgets do not have a visual impact, but only exist to add some logic to their child widgets. So every element is a widget, and this approach encourages reusing elements. Maybe you've heard the term atomic design, and this approach encourages that. So you can create a styled button once, and then reuse and give it a name, call it a widget, and you can reuse that widget everywhere in your app. So it's easy to reuse elements and maintain a style throughout your app. So let's look into the code of what such a widget looks like. There are two kinds of widgets: stateless widgets and stateful widgets. And this is a code sample that shows a stateless widget, and in this case, it's a very simple thing. It's just a text. You can see that the widget is a class. By the way, I had a slide on Dart, but the programming language, I think it's being misplaced somewhere. Maybe I messed up the order. So if we encounter it, we'll do a quick thing on Dart. But I think it's easy enough to read. If you can read Java, C#, I think you can follow what this is about. We see this widget class here. I call it simple screen, a sample screen here, but it could be anything. You can call it a title widget, something like that, which is a stateless widget, and stateless meaning that it cannot hold any values of its own. It can just display things. Every widget has a build function, and in its build function, the widget draws itself and possibly its children. In this case, the widget just displays the text, sample text. I hope this is all clear so far. As I said, almost everything in Flutter is a widget. So say I wanted to add some padding to this widget. I have the same sample text as before, but now I wrapped it in a padding widget. The padding itself is a widget with two properties: the padding, it has edge insets of 16 on all sides, and then its child widget, in this case, the same text. And you can see on the right side the result. This is the sample text, but now with little padding. So let's get back to the previous one. Simple. And here we have wrapped it in padding so that we have the sample text padded on all sides by 16 dp or 16 points on iPhone. But this thing is still a stateless widget. That means it cannot hold the data or state of its own, like its name suggests. But it could get data passed from its parent, but it does not hold anything itself. There's another type of widget, the stateful widget. And the stateful widget is a widget which can hold the state, so it can hold data, as its name suggests. Yeah, on the next slide, I'll show you what such a stateful widget looks like. And I know that this is a lot more code immediately to look at. And oh, unfortunately, I had on the left side was a video, but I see it does not play automatically. Oh, well, you just have to assume what it does. When you press the text, the pressed counter is increased by 1, and it shows how that goes. So it is it's quite a large block of code, but I think if you look closely, it all makes sense. So let's try and take it apart from the top down. The sample widget in this case is a class still, but this time it extends a stateful widget. So it's a stateful widget, and that one is a little different. It does not have a build function of its own like the stateless widget. It has a create state function, and that create state in this case creates the state for this widget. The state is its own class that we see lower, and the state holds a property, in this case the click count. Next, we see the function we've seen before, the build function. And in this case, it results in a flat button with a text as its child. So that is pretty simple and similar to the stateless widget, only that the build function now lives in the state and not in the widget itself. It also has an onPressed property. That's the property of the flat button. And that is triggered when the button is pressed. In it, we call the increment counter function that I've defined lower in the class. And this in turn calls the set state in which we update the counter. So you can see the increment counter, click counter plus plus, but that's wrapped in the set state function. Only when you call set state, the widget is triggered to redraw itself. You could just call increment counter and then just one line click counter plus plus. It would still update the click counter, but only when you call set state, the widget knows to redraw itself, and if not, it won't do it. So you won't see the result. So I hope that all is clear enough, and if not, we can get into this a little bit more. Yeah, do ask questions in the Q&A box about this, and if we have time left, we can also dive into the code a bit more. I can even open up Android Studio and show you this a little, show you this live. In the real world, of course, we have to deal with a lot more complex data and a lot more complex scenarios than just having a button that tells you how many times it's been clicked. That is not a very useful app. So in the real world, we have to deal with a bit of more architecture. When making a larger app, it is inevitable that you need to think about an architecture. I will only touch this briefly, as one can spend hours talking about software architecture, but here's how we started at doing things. Some high-level widgets, mostly screens, get provided with a business logic component or a block. And you can, this is one of the things that are not widgets. I know a bit contradictory, I said everything are widgets, not blocks. A block is a business logic component and is very similar to what a view model does in Android native. So for those who are familiar with how things work in Android, you mostly got a fragment which has a corresponding view model. And in this case, a screen widget has the same sort of relationship with its business logic component. Widgets send events to the block, say that a button has been pressed or text has been entered. The block does the business logic, verifying the text, making network calls, calling the rest of the application, communicating with the data layer. And then when its state updates, the widget is observing that state so that it can respond to changes in the block. This has a benefit of separating concerns. The business logic can live in the block, and the widgets can be kept rather simple and stupid. I hope that all is clear, and if not, we can talk about this in the Q&A. I talked about doing this responding to state changes, and we decided to use reactive streams to do that. So for asynchronous operations, as well as responding to state changes, we used RxDart. Unfortunately, that slide about the programming language Dart has been lost on me, which is sad. But anyway, we used RxDart, which is very similar to RxJava and RxSwift, and we have used RxJava for Android for a long time and RxSwift for iOS. So working with RxDart was not very different. One primary difference being with Android, the one thing that I have been most familiar with, is how far down the hierarchy we use the Rx stream. In Android, we were used to using live data in the view model and then responding to that from the UI. In Flutter, we used RxDart also down to the widget level, so that the widgets can respond to a reactive stream coming from the block, and then the block in its turn could use a reactive stream from the data layer, from repositories, even from network calls, and do its operations and business logic to that. And the stream is consumed in the widgets. For those who are not familiar with Rx, that's another topic entirely, which is very interesting, but a bit much for now. For those who are, I think you can make and you can have an idea of how RxDart was used here. So far, I'd like to conclude the more technical stuff here for now. If there are questions, please feel free to ask them later, and we can look into the code, and I can answer all your technical questions then. Let's go back to a more higher overview of what are the pros and cons of Flutter. We have been using Flutter in production for about a year now. We have had good experience with it, but we have also found some challenges. We have right now one guy who is he started out as an Android developer, but he's actually a Flutter developer now. He's doing Flutter full time. And we have this one external developer that we sometimes call upon to help us out. Some pros, benefits of Flutter. Flutter is a great tool, and you can get tangible results quickly. So it is a great tool for prototyping. The flutter.dev website has a very comprehensive getting started guide and a lot of examples. So it's rather easy to quickly get into it and get something valuable, a prototype working. It has a very active community, and a lot of proposals are constantly coming out. For example, one that has been in active debate is the use of semicolons. A lot of languages don't use them anymore, and there's a heated debate going on if we should keep them in Dart or that they are redundant. This active community drives a lot of the development, and it is made by Google, but Google itself does not really give a lot of guidance into how this tool should be used, which is a lot of times it can be a good thing, and they leave it all up to the community to decide the direction. When things work out like they should, we have experienced that a time gain compared to making separate apps, it can be there. So the first app really did lead us to a lesser time spent than making one for Android and one for iOS separately. But it's not a 100% time gain. I think you should think about 30-40% time gain, because you still need to have expertise on iOS and Android. You still need to make it work for both. And there might be unexpected challenges. That leads me to the drawbacks. One thing that we've come up with is there are a lot of dependent external libraries you can add as dependencies for a certain problem, but there's often a limited choice. So there is a library available, but where in the native worlds you can use CocoaPods, you can use Gradle for Android and iOS, and there's a plethora of options for developing certain. And you have a certain problem, there's a library available, and if it does not fit your needs, there's another one. We've experienced that when using Dart and Flutter, there's often only one, and if that does not suit your needs, you end up having to make your own, which is often just a wrapper around native code. But yeah, that is when you're used to having such a large amount of third-party libraries, that can be a limiting factor. I just said it was a good thing that Google does not provide so much guidance, and that is all up to the community. But I've also listed that as a drawback. Sometimes it can be nice if a large organization such as Google has sort of a guidance as to this is the way that we expect you to use this tool. And that they don't really do that. So it's up to you to decide if you like that or that is a negative. So I've listed it on both. Even though it's fairly easy to use Dart and Flutter, you are bound to come to a point where you know the solution with native, but struggle to do it in Flutter. When choosing Flutter, you have to account for this learning curve. You also might encounter unexpected hurdles. As an example, we have recently had the case where the tooltips of selected text would appear below other elements and be cut off. This is something you don't have to think about when developing for native, and suddenly it happened in Flutter, and we had to come up with a solution for that. This was unfortunate and cost us a lot more time than we initially expected. So please be aware that you can stumble upon unsuspecting bugs. In conclusion, Flutter is another tool in your toolbox. If you find the right use case for the tool, it can come in handy. But that's also one of the biggest challenges. How do you find beforehand what is the right use case for this tool? And you can also think about that the other way around. What is obviously not the right the right use case for this tool? We've experienced that we can gain a lot from having someone around who had already had some experience using Flutter. So having some expertise at hand can really make the difference. If you do want to use it for prototyping, it's a great tool for that. It can lead to very quick results, but it is no silver bullet. You can there are obvious cases where you could better use another tool, just going for native or maybe another platform. And those cases include where you rely a lot on hardware, for example, Bluetooth connections, NFC, or platform-specific features. If you really want to do that, you might have to second guess if this is the right if Flutter is the right tool for you. Thank you all for your attention.